Good day, grade 11. In this lesson, we're going to be looking at vectors in 2 dimensions, and specifically, we're going to just be revising vectors and scalars. So, everything we measure can be divided into 2 groups, either scalars or vectors. Your scalar is a physical quantity that has magnitude only. In other words, it just tells how big it is, but there's no direction. So it only tells like 10 kilometers, 3 kilometers, whatever. There's no up or down, sideways, left or right. Whereas a vector is a physical quantity that has got magnitude and direction. And it represents, you can see that there's this F dash here, and you can see that this F dash with a little dash at the top represents the force vector, where F represents the magnitude of the force. Now we don't really use that so much anymore, but if you see it, then that's what that means. Right, so just to give you examples of scalars and vectors, which you should already know, distance is a scalar. In other words, it tells us how far we've run, okay, or walked, whatever. It's usually measured in meters or kilometers. The SI unit for distance is meters. Displacement is basically how far we are from where we started. Okay, how far? In other words, your distance will be something like you could travel from here to there. That would be A, and then we could go down a bit, and that would be B. That would be your distance, and your displacement is as the crow flies straight across. And what else does displacement have? It has a direction. So it's not just the magnitude, it is also the direction. Another example of a scalar is mass. In other words, this has how much matter you are made up of, so it's always measured in kilograms or grams. Weight is the force with which you are attracted to the center of the earth or whatever planet you're on, and this is measured in newtons. So that is a vector because it's a force. It's a force. Speed is just distance over time. So distance is a scalar, time is a scalar. So speed equals distance over time. Whereas velocity is equal to displacement. Displacement over time. And therefore, because displacement is a vector, velocity is a vector. Time, as you know at the moment, we cannot travel back in time or any other way except forward. So time is a scalar. Acceleration is the change in velocity over the change in time, and since velocity is a vector and time is a scalar, acceleration is a vector again. An electric charge, in other words, whether or not you get shocked by lightning or whatever, electric charge is a scalar as well. So those are just examples of scalars and vectors. Guys, you should know this from grade 8, grade 9, and grade 10. So this is just a quick revision. Now, representing vectors, we always use an arrow. It tells us how big the vector is and the direction of the vector. In other words, if we've got a very long arrow, it means we've got a very big vector, and it's obviously in this direction. Or we have a little vector like that, it means it's a small vector, okay, tiny, so in other words, it's either short distance or small force, and that is the direction. Now there are 3 ways we can represent the direction of the vector. We can either use compass, or we can use bearings, or the direction of a vector relative to another vector. So let's just go through these 3. The first one is a compass. As you know, there's north, then there's east, south, and west. And we always tell our directions with respect to these 4 cardinal points. So for example, this vector 1 we could say is 3 degrees east of north. North of east. 30 degrees north of east. We could have also said that it was 60 degrees east of north, but we always go from the side that it's closest to. So this is 3 degrees north of east. Okay, if we look at another one, our second vector, you can see that this is 3 degrees east of south. Okay, because we're telling you it's 30 degrees. So it's 30 degrees east of south. And again, we're going from the side that it's closest to. So your compass readings are always with respect to the 4 cardinal points. Okay, bearings are always from 0 degrees, and it's always taken from north. So north is 0 degrees. Then we've got east is 90, south is 180, and 270 is west. So this is north, east, south, and west. So if we've got V1, which it tells us is exactly like it was before, basically it is 30 degrees north of east, it's now on a bearing of 60 degrees. In other words, we're saying from north, it's on a bearing of 60 degrees. Okay, whereas here with V2, we are saying that it is on a bearing of 210 degrees. In other words, it's actually 30 degrees west of south, but from north going all the way around, it is 210. How do we get that? That's 0, 90, 180 plus a 30, that's 210 degrees. So it's always taken from north. Right. Now, the other way we can do this is, and the last way we can look at it, is the direction of a vector relative to another vector. So in each of these cases, vector A is at 30 degrees to vector B. And you must remember the direction of the vector is always measured at the tail of the vector. So here we've got A and B, right? And we're saying that they are 30 degrees from each other. Yeah, we've got A and B, and again you'll notice that our tails are together, and then we've got A and B. So when we're looking at this there is the 30 degrees because we take it from the tail of the vector. That there is 30 degrees, and that there is 30 degrees. And that grade 11s is a quick revision on your vectors and scalars. Please make sure you understand the difference between vectors and scalars, and also how we can measure them. Thank you. Have a great day.